Okay, today is 4.7.2, and I'm going to start with a review of 4.7.1, which was all about inverse trig. And it's been a weekend, so I know you very well could have kind of forgotten how to do this stuff. But I asked a question to get it, and it said this: arc cosine of 1/9. What I'd like you to do is listen to a little bit of explanation here, and then see if you can remember how these work, and tell me what the answer is on get it. And you don't have to submit it yet. If you have it, awesome. And then next to the question, when you put it in through get it, there's an option right as you're typing the answer in to say how confident you are in it. And there I'd like it if you would say, you know, like so it's in bars, which kind of makes sense. I'm a 1 bar, which is kind of like a weak signal, right? So same idea. If you're a 1 bar, as far as I don't understand this very well. Okay, so here's what I would be hoping you were thinking. Arc cosine just means inverse cosine. Inverse cosine means that you rewrite it, and I hope you don't type this answer in. It's a good first step, but that's not the answer. This is the first step, rewriting it to see, oh, I guess I need an angle. That's all that step really does for you, is tells you they've given me the sides, and I need an angle. And now, what angle is it? Well, you go, and I hope you remember that cosine could be positive a half in 2 places. You might be wishing you could take your answer back. Cosine could be positive a half in 2 places, but cosine's positive here and here, and not there and not there. So why is one of these two also not going to work? Do you remember where inverse cosine is allowed? Do you remember? Does anybody remember where inverse cosine is allowed? Yes? All right. Well, cosine is only allowed here and here. Another one that is commonly referenced is that from here to here is where tangent and sine are allowed. This is inverse tan and inverse sine. And this red one is where inverse cosine is allowed. Okay, so since we're doing inverse cosine, let me back this up now. You get, if inverse cosine is only allowed from here to here, that means I have to throw that one out. Okay, so that's why there's only going to be one answer for this, because inverses are only allowed in certain places. Hopefully you drew it right here, and if you just got lucky because you drew it there, then think about that. Not all of them are going to be there. Okay, and now I say cosine. Adjacent over hypotenuse. Adjacent is 1, hypotenuse is 2, and this must be in the square root of 3. What angle is across from the square root of 3? 60. So therefore the answer is 60. Except it's always in radians because they ask for exact answers. A lot of people get confused by that. Put that cell phone on my Is your regular iPad not here? All right, I'll make that acceptable. I do want you to tell me when that happens so that I don't have to do that. Okay, so back to, we want to say 60 degrees, but we want to say it in radians because radians are a way to give an exact answer. I'll explain that more to you later, but whenever you see exact answer, think radians. And we've been pretty much doing them all in radians. So, instead of 60, we're going to say pi over 3. And there you go. Pi over 3. That is what 60 is. Okay, yes. Okay, good question. How do you type that in to get it? All right. Here's how some of the kids did it. Someone typed in PI/3. I agree. Nice job. I had some people say PIE. That's fine. The abbreviation for pi is usually PI. But, hey, at least they had the idea. All right. Now, I told you that one, so that shouldn't have been too tough. When I ask you the next question, I'm not going to just show you how to do it. I'll ask you to type in your answer to get it, what you've done, and then type in how specifically on that problem, how confident you are on the answer. Okay? So let's do another one just like that. Notice my steps. I rewrote the thing. I rewrote it, and then I drew a triangle. And then I was careful to only do it where certain things are allowed. Like, for instance, if I give you an inverse sine question, do you get that inverse sine's only allowed in here? So I can right off the bat go like that? Okay. And if I give you an inverse tangent, it'd be the same thing. And if I give you an inverse cosine, then these two aren't going to work because inverse cosine is only allowed in here. Those are the first things you cross off. Then, if I give you a thing like cosine comes out negative, well, use your other rules. A, S, T, C. Where's cosine? Positive? Here. So cosine's negative there, so it can't work if cosine. If I give you cosine is positive, or if I give you cosine negative, it would work here. All right, I'm going to give you one for that. Cosine of this particular angle comes out to negative 1 over root 2. Now, how would I say that in inverse trig? Inverse cosine of 1 over root 2 with a negative on it. Pause for a second. We give that one a shot. You got the answer. Type it in. I will give you a question in a second. Get it. Okay, so quick. We did talk about this briefly while I was on pause, but the answer ends up over here. I think most people knew that. And adjacent over hypotenuse, adjacent side is negative 1, hypotenuse is square root of 2, and most people knew this side was then therefore 3. Wait a minute, something's wrong. No, it's not. It's a 1. It's a 1, okay? Then, most people recognize, oh, 45, 45, that's a 45, and if they were extra smart, they said, okay, that's pi over 4. They were extra smart. They didn't say pi over 4. They said, oh, that's just the reference angle. That angle is 3 pi over 4. Okay. All right. So that's, sadly to say, just a review. I haven't done anything new yet. That's what you did on Friday. And maybe forgot over the weekend. Okay. So let's talk about what's new for today. It would be the same exact thing, except the question would have a nested parenthesis. And this would be like the beginning of the question. And then you might be asked to do the sine of that angle. And I know it seems really complicated, but it's really not that bad. Where do you start when you have nested parentheses? Start on the inside. And that's what I've been trying to coach you at. Remember, on all those other problems, you had a choice, start on the outside, start on the inside. It's another one of those times. You start on the inside in most complicated math problems. You say you start on the inside. You already did this. Let's not redo it. We just did it. It was the answer to it. 3 pi over 4. So really now the question becomes sine of 3 pi over 4. And that's not that bad. In fact, I've even got the triangle already drawn. See what I mean? Because I can keep that same triangle to do this, because 3 pi over 4 is over there. It's over here. That's where 3 pi over 4 is. So I don't have to redraw the triangle, but I use different things off the triangle. The sine is opposite over hypotenuse. Notice this one doesn't have a negative. 1 over root 2. Final answer, 1 over root 2. You get how it's just like you do the inside one first, and then the answer, once you got that, it's no big deal. All right, so let's say, here's an example that's extremely easy. Sine of 1/4 plus 1/4. Okay, this is not even like what you do today, but it's the same concept. Where would you start? 1/4 plus 1/4, which makes 2/4, which is what? A half. Oh, half is right, I meant inverse. So we'd start on the inside, and we'd say, oh, that's really a 1/2. So now it's inverse sine of 1/2, and now that you could do. So inverse sine of 1/2 means like sine of some angle is a half. And then you ask yourself, isn't there more than one possible answer for this? More than one possible answer for sine of something is a half? Yeah, there is. All students take calc. Sine of some angle is positive. Oh, so it has to be here or here. Can't be there, can't be there. Now I ask you something that I need to explain to you further, but I'll be honest, I'm not positive right now myself. If this had been an inverse sign question, it would only be allowed in there and there, and therefore I should cross off S. Well, it was an inverse problem here. Let me think. So since the original problem was an inverse problem, you get I'm now confident. I should use this rule that it's only allowed from here to here. So I should cross this off. Did you get that? Because I was doing an inverse sign problem. Then I got to use that rule that inverse signs only allowed from negative pi over 2 to pi over 2. So then I should draw it in here. You know, these are really messy. Maybe over here I should start over again. Now that I know it's supposed to be in quadrant 1. Signs opposite of hypotenuse, opposite is 1, hypotenuse is 2, that's square root of 3, and therefore what's cross root of 1? This angle right here, which is a what? Pi over 6, also known as a 30. But since we're supposed to give exact answers, pi over 6. Why didn't it give this other answer that would be over here? Because inverse sign's not allowed over there. I had to work it through in my head first to make sure I wasn't making a mistake on that. I did make a mistake like that in the other class. All right. Now let's do one off the sheet, but first the question is, you can find your worksheet 4.7.2. Nope, I said the angle was 3 pi over 4. That's 3 pi over 4. Hold on. And I just want to clarify what you said, because you didn't say it right. This angle that was in there was pi over 4. That's a reference angle. This is the reference. And you don't give that answer. Why? Because that's not where our answer is. Our answer is actually being drawn over here. So the answers for these are where they are. In this case, 3 pi over 4. If something's drawn over here, the angle you get is the reference angle, and it's the actual angle. So then that's really simple. But if it's drawn any other place than here, like if it's drawn not there, but over here, for instance, then you never give the reference angle as your answer. So if this angle had come out to pi over 6, I wouldn't be able to say pi over 6, because pi over 6 is actually over here. Pi over 6 is my reference angle, and therefore the answer is all the way around to there, which is 6 pi over 6 plus another pi over 6 is 7 pi. Okay? So always give the 7 pi over 6 type answer, unless you're in quadrant 1, where the reference angle is the answer. Okay? All right. Okay, now let's get to a few problems off 4.7.2. If you haven't got your iPad, you'll have to copy these off the board. Give me just a second to pull it up. Okay, so here's our problem set. That very first one. Number 1. So, inverse sine of a half. My first thought is rewrite that puppy as sine of some angle is a half. And then doesn't it just, I hope it pops in here. This is the one I've told you. We would do like 35 times. We're probably that lever. What is the angle set? 30. Why can't I give a second answer? Because this is inverse sine, and you're only allowed on inverse sine to be there or there. Remember what's the same as that? Inverse sine, and what else is this? Inverse tan. Yep. Inverse sine and inverse tan. If you're not good at those yet, maybe you should copy this at the top of your page, because we're going to use this over and over again. Next part is cosine, and cosine is only allowed there. Inverse cosine is the green one. Sine and tan are the blue ones. Okay? Now, even more specific, do you remember how tangent has asymptote? And so it can't touch these spots here, here. Can sine actually be accurate on your drawing? You'd have to have a separate one. And the sine one can touch, so maybe I'll just grab this and move it over. Oh, maybe that'll set to stay as a tangent one then. It doesn't quite touch. And the sine one actually touches there to there. Okay, maybe I'll leave that drawing there for a while I do the next property. Okay, now why is sine only one answer? Because inverse sine is only allowed, and inverse sine is positive right here. So it's only in that quadrant where I get an answer. In that case, it's 30 degrees. Also known as pi over 6. So I'm going to cross this off and say cosine of pi over 6. Now, remember, this is not cosine of some angle is pi over 6. This is cosine of pi over 6. Also known as, if you want to do it in your head, cosine of 60. Oh, wait, 30. Can you change over to degrees? Yeah, you can as long as your answers are in radians. Cosine of 30. Remember, one place where we're allowed to do this and have cosine of 30. 30 degrees is right there, and it's only right there. That's actually more like 45. A little less than that. Anyway, cosine of 30 is right there. So cosine half adjacent over hypotenuse. Cosine, this is 30, that's a 1, and that's a 2, and that's a square root of 3. And this is 30. And then cosine of 30 is adjacent over hypotenuse. Adjacent is negative, not negative, it's root 3 over 2. How many of you guys had root 3 over 2? Okay, awesome. I was asked by a kid to do number 5. And I agree, that's a tricky one, so I will be glad to help with number 5. Everybody please get to number 5. The reason it's tricky is because cosine is equal, or cosine of some angle, see I'm translating, is 1 over 1. How can the adjacent and the hypotenuse be the same thing? Is that a normal triangle? No, it's not. It must be a quadrantal. Very good. So this has to be a quadrantal. It's either here, or here, or here, or pick another color. I'll use this. Okay, it's one of those 4 directions. Cosine is 1 over 1. Do you remember the deal? Sine is which letter? Sine's y. Cosine's x. Okay, so x is 1, really. X is 1. Where is x? Well, this is where y would be. This would be where y would be negative. This would be where x would be negative 1, and this would be where x is positive 1. Right there. What's that spot called? What comma what? Y0. And therefore, if I pick the x of it, I'll have the answer. Now, what's the degrees that go with it? In other words, see, I was trying to figure out what degrees, right? I'm trying to find an angle. What degrees is that? 0. Good question. Where is cosine allowed? Is cosine allowed out there at 2 pi? Cosine's only allowed, I'll sketch it for you again. From there to there. Just to clarify, that's from 0 to pi. Inverse cosine's only allowed from 0 to pi. So should we pick 0 or 2 pi? 0 is not allowed. Once again, 0 wins over 2 pi. That's a common theme in our trig question. Okay, so I got 0, but is that the final answer? Nope, that's how many degrees, or in this case radians, that this was. Now, this next one is not tangent of theta equals 0. That's the screw up I made in my 3rd hour class. I was thinking tangent of something is 0. No, this is tangent of 0 is something over something. I'm trying to find the side. I already know the angle. This is not an inverse tan question, is it? Regular tangent question. So it's tangent of 0 degrees. So then you just have to ask yourself, where is 0 degrees? It's right there. That's where 0 is. That's where 0 degrees is, right? Well, 0 radians is the exact same spot. So then, kind of weird, but I'm going to use the same exact point and find the tangent of it. Sine y, cosine x, what's y over x? Y over x. What is the y at that spot right here? Y is 0. Over the x is 1. Is 0 over 1 legal? Yes, it is. And what's the answer? 0. That can be confusing, no doubt about it. Now, if you put a 0 degrees on it, that would be sadly wrong. Because remember, we said we were going to give answers exactly, and therefore, it is 0 radians. We just say 0. Radians don't have units. Whatever you do, don't put a degree sign on it, or I'd have to mark it wrong. Then you're giving an answer that's in degrees, not radians. Yes. Okay, why wouldn't I do the 1, 1 square root of 2 triangle? Good question. This started off as a cosine question. And cosine is defined as, look at the red. Can you focus in on just the red writing here? Okay. Cosine is defined as the adjacent over hypotenuse. Do you get how if the adjacent is 1 and the hypotenuse is 1, it can't be a normal triangle? You were thinking of like tangent. If it had been tangent like this, instead of an inverse tan, then we'd be doing exactly what you said. We'd be doing 45 degrees. This is cosine, so it's adjacent over hypotenuse. That told us it couldn't be a normal triangle. Therefore, a quadrangle, etc. All right, well, let's just pick one more and do another maybe weird quadrantal one. Let's do number 10. Everybody look at number 10 with me. I'm going to get you partway through, and then I'm going to ask you to turn it my way and show me what you think the answer is. All right. First thought is I'd rewrite that. Sine of something is 1 over 1. Sine's opposite of hypotenuse. This is one of those not normal triangles. So you figure out where it is. And then you figure out, okay, so I found the number of degrees it is. And you do the tangent of that. Once you know that this came out to like 3 pi over 2 or whatever it came out to, then do tangent of that. Pause for a second, give that a shot. And I'll answer people whether or not they're right when they turn them. I'll give you a hint. We're doing tangent of some angle. And that also will be a quadrant. Well, just for perspective, about half the kids were able to answer. For the other kids, listen, so you can see. You should have said that sine is like y, and y is 1. Where in these spots is y 1? That's where y is 1. 0, comma 1. That's the only spot where y is 1. And therefore now I should not give an answer of 1. I should say the theta. Sine of what is 1? Sine of pi over 2. So then, after you got pi over 2, you had half the problem done. Now you do tangent of pi over 2. Tangent at this same spot. Tangent is y over x. That's 1 over 0. Wait a minute. 1 over 0 is not a great answer because that's undefined. The answer is undefined. I'm just joking. 1 over 0 equals u and okay, a lot of people agree. Okay. All right. But you are in a challenging math class, and it's just started to step up. I warned you that the trig would get hard, and it's getting hard. It's not impossible, but it's getting hard. So take your time. Every single problem I did, you see I have a picture for it. Unless you think you are way smarter than I am, you should probably have a picture. You should be doing a picture for each one of them because it really helps make it less abstract. So you need work. If you showed a lot of work and it didn't include a picture, I guess I could live with that, but you really should make a picture. Okay? And notice I always start by rewriting these inverse ones to not be inverse. All right, so that's another part of doing these problems. And then at the very end, make sure you circle your answer because these things get really messy. So I should probably put a box around that or something. Because we are going to be grading homework tomorrow. Do a good job. And I got to keep doing the grading and putting it in the grade book or kids aren't going to do their homework. I understand that, but it will really mess you up if you get into the hardest unit of grade. Stop doing homework. You're just all right. That's all I have for you for today. Say.